Yes, sir.
Good. Good evening. Only one student today offline.
Good evening, sir.
Okay. So last class we have seen EOQ problems, right? We have seen till illustration 22. I have given some homework. I hope you guys have done it. Yeah? Okay. So now today we'll start with illustration 23. Okay? Illustration 23, this is a different kind of a problem, different pattern. Page number 83. Okay. So he says consider an EOQ case where annual demand is 1000 units, economic order quantity is 200 units, the desired probability of not stocking out is 0.95, that is 95% probability. The standard deviation of demand during lead time 6, it is not 6L, this is standard deviation, so it is sigma. Uh, sigma, yeah, is 25 units and the lead time is 15 days. Determine the reorder point. Assume the demand is over 250 week day year. Okay. Okay. So these problems he has given us. Okay, so last class before closing we have discussed one topic, one small thing, right? So we have told reorder level is equal to average demand into lead time. So we have solved problems with this formula, right? But we have also discussed that this is cutting it to the edge. So we have sometimes told there will be something called as a safety stock. Okay, SS. So sometimes the management wants to keep a safety stock so that if you're at the reorder level, if you order your quantity, if it doesn't reach on time, we will still have raw materials for the production activity. Okay, so there is safety stock. Okay, so now in this kind of a problem where he will give you a percentage for not stocking out, okay, or this is also called service level. He might use a different term, so it may also be called as service level. Okay. Okay, so how do you solve this problem? Yeah, so the formula is reorder level equal to daily demand, or average demand average usage, actually average usage into lead time plus Z into under root of L into standard deviation. Okay, so this is nothing but the probability coefficient. Okay, and then this is lead time and this is standard deviation. Okay, so this is the formula we have to use for finding the reorder level. So please note it down because it is not clearly mentioned in your book. Okay, okay, now coming to the problem. So he gives us an annual demand. So annual demand equal to 1000, and he says so we need average usage. Okay, and he has given lead time of 15 days. This is in days. So last class I have also told you, while you are using this formula, you have to see the units. Okay, if this is in weeks, this should be in weeks. If this is in days, this should be in days. So now for average usage, we have to use days. Okay, so this is per year, and he says in 1 year there are 250 days. Okay, assume 250 days in a year. Right. So your average usage equal to 1000 divided by 250. That is 4 units per day. Okay? Yeah. So we have average usage, we have lead time. Okay, now what is this probability coefficient Z? Okay. Okay, so standard deviation also he has given. He says standard deviation is 25. Now Z. So there's something called in operation management, not in operation management, in mathematics, there's something called as a Z factor table. There's a Z factor table. So this is actually a high level mathematical derivation, but what it is it simply gives you the value of Z for a certain probability. Okay. So for a certain probability, say 90%, 95%, 85%, so these are probabilities, right? For each probability value, you will have a Z coefficient. Okay, you can Google this Z factor table. Okay, generally this should be provided to us in the form in the problem, or he has to give us that table for us for reference. So the table is simple. You can just Google it or YouTube it how to read that table. But here, in our case, the probability is 95%, and for that probability, the value of Z is 1.64. This will come from that table. From the table. So there's a Z factor table. So that table, this is a constant table. It's a universal table. So you can Google that. I'll show you the table. Yeah, in question he has to give you the value, but here he has not given you the value. So if you just Google that Z score table, you will find that. Z factor or Z score table. Okay. So I did not have the projection of it, but you can see. So I'll show it to you. So this is the table. So here the probability is 95%, right? So you have to see 0.95. So here it is. So it is 0.945 and 95, right? So this is 1.6, and then this is the 0.04. Okay. So 1.604, this one. This is this. After that is crossing 95. So he has taken 1.64. Okay. So this is a universal table. I will share you the link of this table in the group. Okay. So for every probability, there's a constant value. So this there's no need for us to derive or know. That should be provided in the question. Okay. Yeah. So now coming to this. So this we know it is 1.64, and lead time is 15 days. So let us just apply the formula. So reorder level equal to 4 into 50. Yes, when you have this probability. Correct. If he doesn't give you the probability, then it is only we have average into the lead time. Actually, it is maximum usage, but if he doesn't give the maximum usage, it is average usage. 4 into 15 plus this is 1.64 into under root of 15 into 25. Okay. So here he has made a mistake, but this is the formula. Okay. How much is it coming to? This is 60 plus 15 under root into 25 into 158.
Total
208. Yeah.
218.79.
Yeah. We can round it to 218 or 219. Yeah. So don't worry about the Z. This should be provided to you in the question. Okay. But for 95%, it is 1.64. Yeah. Okay. Let's look at the next problem. It's a similar problem. Illustration 24. Yeah. Okay. So here it says the daily demand for a certain product is normally distributed within a mean of 60 and a standard deviation of 7. Okay. So he has given you a mean of 60 and a standard deviation of 7. The source of supply is reliable and maintain a constant lead time of 6 days. So lead is 6 days. The cost of placing the order is 10. So order cost is 10. And annual holding cost is 0.5. So this is carrying cost. So that is 0.5. This is per unit. And this is per order. There are no stock outs and unfulfilled orders are filled as soon as the order arrives. Okay. Assume sales occurs over 365 days. Okay. Find the order quantity and reorder point to satisfy 95% probability. So is given probability as 95% of not stocking out during lead time. Okay, it's the same problem, but here he has asked to find us the order quantity. So EOQ also we are supposed to find. So EOQ is nothing but 2 AS by C, right? So that is 2 into 60 into, so mean is nothing but average, right? Yeah, 2 into 60 into 365 into order cost is 10 rupees, right? Divided by 0.5. So he says 936 units. You can check. Yeah. Okay. So that is the first part. Now we will go to reorder level. So reorder level, the same formula which we have used. Average is 60 into the number of days is, lead days is 6 plus, so it is again 95% only. So it is 1.64 into, this will be under root of 6 into 7. How much is this? So this is 360 plus 27.5. Okay. And he says the sum is 188. It cannot be 188, right? So 188, yeah. 388, yeah. So the reorder level is 388 units. Okay. Yeah. So see, please attend the class because there are a few mistakes in the book. Okay. While if you study directly from the book, you will not know that these are mistakes, right? Yeah. Okay. Okay. Let's go to the next problem. This is almost a similar problem, but here there's a small variation. Okay. Here he says the daily demand for a
Sir, I
product
have a
is 10
question.
units with a standard deviation of 3 units. Okay. So we know the daily
Sir,
demand
I have a question.
and standard. Sorry.
What is this 17.15? Like they have given in this question, the illustration 24. Sigma 1, this summation, then sigma d 6 into 7 squared.
Yeah. So this is a formula. This is a different formula, but we can follow this formula. Okay.
Okay, sir.
This is the formula which we have to follow. So this is a different standard deviation kind of a thing he has given. That is a little confusing, but this formula, this is even clear. You can follow this formula. Okay.
Okay.
Okay. The standard deviation is 3. Okay. Now he has given us a review period. Review period is 30 days. And lead time is 14 days. Okay. And he says the probability of not stocking out is 98%. Okay, for 95% we knew the value. So for 98% the value he has given for Z is 2.05. Okay. Okay, and he also says, he's given us one more information that he says there is already 150 units in the inventory. Okay. Okay, so this is okay. So in our formula for reorder level, we have average usage into lead time plus Z coefficient lead time into standard deviation. Okay. But here if you see there's a review period. So that means every 30 days they review the stock. So generally what happens if you review the stock daily, you will get to know the stock level daily, and if suppose it hits the reorder level today, you will order it today. But here the management is not reviewing the stock daily. So they are reviewing it every 30 days. So necessarily what happens, your lead time will change. So this lead time will be modified to the total review period plus lead time. So because you are taking a look at your stock only after 30 days, so it will take 30 days more for your stock to arrive. Correct. So this thing, what happens is, this will become your average usage into your review period plus lead time, okay, plus the same thing Z, and lead time here also will be the review period plus lead time into standard deviation. Because you are not reviewing your stock daily, so you are placing your order 30 days late. So for that 30 days also you have to take into account your reorder level. Okay? Okay. And here he says there's an initial inventory of 150. Right. So this becomes, so you have to have minus the initial inventory, right? Because you already have an initial inventory, unless and until that inventory runs out, then you will have this additional inventory in place, right? So your reorder level will hit only after this inventory also goes. So this is the modification. Okay, so when you have a review period, your lead time will get increased by that review period. And you have to take into account the initial inventory also. Okay? Yeah. So now let us calculate the reorder level as per this thing. So average is 10 units per day. 10, right? Yeah. Into, now this is your review period plus your lead period, plus Z is given as 2.05 for 98% of probability, into your standard deviation is 3 into under root of 30 plus 14. Okay? Yeah, minus 150. Minus 150, which is your initial stock. So here you will get let us calculate. Okay, so you complete this calculation. Yeah.
This
330.
is 480.79 minus 150.
So it is 331 approximately. Okay. Yeah. Okay. So coming to the next problem. Average inventory suppose the following item is being managed using a fixed order quantity model with safety stock. Okay, so that is fixed order is our, generally it is EOQ, it is our reorder level, that is your average usage into lead time plus safety stock. Okay. He says annual demand is 1000 units, order quantity is 300 units, safety stock is 40 units. What are the average inventory levels and inventory turnover for the item? Okay. So like we have seen the average inventory while we were calculating the carrying cost, average inventory is nothing but EOQ by 2, right? This is because we are taking the assumption that initially the stock is 0. So closing minus opening by 2. So your average inventory is nothing but, so what is the order quantity which he has given? 300 units. So 300 by 2, and plus you will always have a safety stock here, right? So that would be 40 units. So it is 190. Okay. And inventory turnover. So inventory turnover is nothing but your total demand by your average inventory. Right? So that much inventory comes and goes. So how many times that happens? That is your inventory turnover. Okay. So that is nothing but 1000 by 190. So it is close to 5.26 times per year. So you have an inventory turnover of that much. Understood? Okay. So illustration 27 and 28, please do it as a homework because it is the same. 28, we have seen similar problems in the last class where you have a percentage of discount they are given for some individual breakup of units. So you will have to calculate the total cost of all the levels that he has mentioned in the problem. Okay. You kindly do that and let me know if you have any questions. And illustration 27 is the same problem which we have solved here. Okay. Okay, illustration 29 we will see at a later time because this has probability and this we'll cover in a later chapter. So we'll come back to this. Okay. Yeah. So, okay. So illustration 30. This is a similar problem. Okay. I'll just briefly explain. You can do the math later. Here he says the average company has 200 units of product on hand. So that is initial inventory, it is 200. Okay. And that the order of product on hand, it orders every 2 weeks when the salesperson visits the premises. Okay, so the salesperson will come to the premises every 2 weeks. So that means that is the review period, right? So that person will come into your factory and he will review the stock, and then if there's something, he will order. Okay, so review period is 2 weeks, that is 14 days. Okay. Demand for the product averages at 20 units per day. So demand is 20 units per day. Okay. He has given a standard deviation of 5. Lead time is 7 days. So lead time is 7 days. Okay. Management has a goal of 95% of not stocking out. So 95 is the probability. So that brings Z to 1.64. Right. The salesperson is due to come late this afternoon when 180 stocks are left in the stock. Okay. So generally the initial inventory is 200, but he's saying that your salesperson will come late. So he will come at 180. So when the inventory is 180, then your salesperson will come. So the initial inventory at the time of reorder will be 180, not 200. Okay. So he is just confusing you. So you have to not let him get confused. Okay. So now he says how many units should be ordered. So reorder level. So same formula. Okay. So you have per day 20 and you have review period plus lead time, right? So this will be 14 plus 7. Okay. Plus Z, you have Z is, what is Z? 1.64. 1.64 into again under root of 14 plus 7 into 5 minus 180. So this is your reorder level. Okay. Yeah, you can solve. I think it should match your answer. Yeah. Okay. Yeah. Okay. Okay, coming to the next problem. So this I think you have already seen in your group 1, but I'll just tell you. So this says solve the ABC analysis of the table and show graphically taking percentage of a list of different stock items. Okay. Okay. So in ABC analysis, So for category A takes the value, so value of inventory as a percentage. Based on that, they give the categories of A, B, and C of your total inventory. Okay, so your total inventory will be 100%, right? Total inventory will be 100%, and A will take from 70 to 80%. This will be from 15 to 20%, and this will take 5%. Okay, so C will be less than or equal to 5, and A will be in this range. A and B will be in these ranges. Okay, now he has given item numbers, and he has given the annual usage, and he also has given the percentages. So he just says us what items should be placed in which category. Okay, so if you see, this is a very straightforward question. So we have, let's come from C, it should be less than 5%. Okay, so if you see for C, up to from 54 to 41, it is coming as 4.5%. So he has placed that in C. Okay, if you go one up, if you go to 82, you cannot take 82 because 82 itself is 5.57%. Okay, so from 54 to 41, it is coming less than 5%, less than or equal to 5%. So that is placed in C. Okay, then again going upwards, so you can sum up till 27. So 27, 03 and 82 will come to 22.7%. If you take one more item, say 68, that will again cross 50%. Okay, so you cannot take 68. So 22 and 68 together come to 73%, and 54 to 41, the last things come to 4.5%. So this is C, this is A, and B you have 27, 3 and 82. Okay, so this comes to 22.7%. So it is just categorizing your inventory items into A, B and C categories. Okay, so this percentages you kindly remember. So the value of your inventory in A should be from 70 to 80, 70 to 80%. B will be from 15 to 20. So 70 plus 20 is, okay, 25. Okay, 15 to 25%. So 70 to 25 is, sorry, 70 to 20 is correct one, sorry. (15 to 20%), and C will be less than 5%. Okay, this should be your inventory levels for ABC analysis. Fine. Okay, so let us start unit 3 today. So today we will complete unit 3. Unit 3 is nothing, it is basic theory, and most of this which we have already seen in unit 2. So some things repeat, and some things is few additional things are there. Okay, so unit 3 is mostly theory. So we will be starting with the module 3. Okay, so we will be starting with product design. Okay, okay, so we know that any organization will have to either give products or provide services, right? So this is the business of any organization. Okay, So while it comes to product design, so what is product design? So design is something which is specifications, right, or configuration of product. Okay, so if suppose today one company it wants to introduce a new product into the market, okay, so what the company has to do, or what characteristics should its product have, and what process it should follow while designing the product. Okay, so we will be looking at those processes, right? Okay. So we will see what are the objectives of product design. Okay. So basically there are three objectives. One is to design and develop a product which will fulfill the customer needs. Okay. So if your product doesn't do what the customer needs, what the customer wants, then your product is not designed correctly. Correct. And it has to minimize the cost and maximize efficiency. So these are the objectives of product design. Simple, right? It should fulfill your customer needs, and it should be able to do that with minimum cost and maximum efficiency. So that should be our objective while designing any product. Okay? Okay. Now we will see what what are the steps, or what are the activities for product design. So activities of product design. Okay. One is to understand customer needs. Okay. Yeah. So we can take a look at the, one second. So you can take a look at the figure he has given in page number 90. Okay. So he has outlined all the activities of a product design. Okay. So we can see what are the activities that take in designing a product. Okay. So we can just summarize them as process of product design as simply first is customer understanding. Okay, customer needs understanding, and then user friendliness of the product, right, and it should have a balance between the cost and output, or features provided. Okay, then quality of input and output, presentation etc. Okay. So we can see this is basically what goes into product design. Okay, first thing we have to have a clarity in customer understanding. Okay, so the customer sometimes maybe he cannot clearly give out what his needs are. So for this we have to go into a deep dive. You know, we have to sit with the customer and we have to understand what he is looking for. Okay, so this sometimes, you know, sometimes you have to see where he is using it. So suppose if it is a tractor or something, say, and we need to design a product for a tractor, so for agriculture, so we have to see where exactly it is being used. So there are many machineries, right? So they use it for plowing, sometimes they use it for harvesting of your crops and everything. So an exact understanding and a clear definition should be formed before starting the activity of development. Okay, and then whatever we develop, we have to aim for the user friendliness, because if there's a lot of technical activity, or you know, there's a lot of hardship in using your product, so that will not be used by the customer, right? It is not very helpful for him. So you are creating a complex product for him, so that is not very useful for him. So it should be user friendly, and it should always have a balance between your cost and your price and what you are delivering. So there should be a balance between these two. Okay, so you cannot say that I have given you everything you have asked for and you ask an exorbitant amount, so that will not do. So because you'll also have to see the competition, right? So not only you are manufacturing the product, there are many competitors. So if you are not price effective with your competition, then your product, you know, it will not get the enough market share, right? And then the product should be of quality. So it should not, you know, you give him everything and you give it to him at a good cost, but if it doesn't work after say 10 days, then your customer relationship, you know, so the customer satisfaction is not there, right? So your customer satisfaction is not there. Okay, and the presentation of the product. So basically your product should look good in physical appearance as well, right? So all of these factors, you know, we have to keep in mind while designing a product. Okay, yeah. So coming to the next part, that is process design. So process design is something which we have already seen, okay, in the previous chapter, where, you know, process layout, while we were talking about layout, right? So we were discussing about types of layouts, right? So process layout or product layout, and it is similar to that. Okay, so he has, you know, it is similar to that only. We can just have a recap. Okay, so here he says, you know, the basic 5 types of processes. Okay, one is job shop process, batch process, repetitive process, continuous process, and project process. Okay, so this thing, which process to use for what product and volume mix, this is a very key decision in operations management. Okay, so we will have a basic look at, you know, what these processes are. So coming to job shop, so this is nothing but you have a very low volume of goods, okay, but a high variety of products. So say you're a furniture shop or something, so you have like very low volume of goods. So say 2 tables, 3 cupboards, okay. So you have more products. So you have, say tables, cupboards, lamps, and then chairs, sofa. So you have more products. So you have like 10, 15 products, but the volume of that is very little. So say 7, you get an average of 4 to 5 per item. So this is, this is a job shop. So you need more skill, people will be there, and then each of that they will manufacture and then they will ship out. So that is a job. And batch process. So in batch process, what happens is, so here you have moderate volume and also moderate, so you have moderate volume and you have a moderate products also. So not very high level of products and not very high volumes. Okay, in that thing what happens, the manufacture happens in batches. So you take 10 of one product, you manufacture, and then again you go to the next batch, you go to the next batch. So that is the batch process. Okay, and in repetitive, so repetitive is when you have high volume and high volume and normal products. Okay, so this is mostly, assembly, a kind of an assembly unit. Okay, so say car, or televisions, appliances, in which you have, where you have process. So as we discussed in that previous class, if you remember, so you will have chassis, you will have engine, you will have interior of the car, you will have a paint, and you will have testing. So this kind of a repetitive process. So for all cars it is the same, so it goes in a product batch, so one division to another division to other division, and it's like an assembly line till the end. Okay, so continuous process is something where the setup, or start and stop, for start and stop is very high, the cost of it is very high. So instead of starting and stopping, you will have to continuously keep running your process. Okay, so say you are manufacturing like paper, sugar, fertilizers, steel and all, where you cannot just stop your process. So if you take steel, you will have melting, foundry, and there are huge machines, right? So you cannot just stop and start them. So what you will do, you will have people in shift timings, and your factory will be running 24/7, right? And project process is something like, it is a very specialized, or when there are huge capital investments, like you're building bridges, you're building flyovers, or huge processes where trains and all, mostly real estate kind of a project. So for that project, you will have a separate process, you will have separate experts of each domain, and then they will decide on how to carry on the work. Okay, so for this, he has given a graph on page number 98. If you can refer to that graph. So this is the PVLF layout. He says PVLF. So PV is nothing but product, V is volume, LF is the type of layout. So which we have just discussed, right? Like job shop, batch and all. So you can take a look. So here if you see products, if you take a look at that graph, many products, few each, right? So this one, many products, few each, it's a job shop. Okay, functional layout, flow extremely varied. So he has given you that graph, in a graph, what process should be followed for the product and volume mix. Okay, and many products and low volume is a batch. Okay, and many products, medium volume, it's operational based, or repetitive and continuous. So yeah, several products and high volume, this is continuous, equipment based line flow. So this is a continuous flow. So this, it is close to continuous. If you have very high volume and one product or several products, so your factory should keep running, and the startup costs and stop costs are very high, so it is close to a continuous process. Okay. And he has given you the same thing in page number 97. If you see, classic way of categorization includes types of layouts. Okay, so process layout, so product, group, and fixed. So this also we have seen in the previous layout thing. So if you remember the fixed one, we were talking where, you know, we have something called like a ship. So if the ship, you cannot move it around, so that will be fixed and all of your things will come and get assembled, right? So this is the same repeat of that. Okay, so you go through this lesson on your own. Okay, so 3.4, 3.2 you have to study. Okay, it is simple. He just talks about the process layouts and the same thing which we have discussed in unit 2. Okay, have a read, and if you have any questions, you let me know. Yeah. Okay. So let us see what a project life cycle is. It's a small topic. So any product, you know, it goes through a certain life cycle. Okay, where, you know, you will have over time what happens to your sales. Okay, so it goes in something like this. Right, so this is your introduction phase. Okay, this is the growth phase, this is your maturity or saturation phase, and this is your decline. Okay, any new product which comes into a market, so once the product comes into a market, so what happens, the companies, they do a lot of marketing, right? They spend a bomb on your marketing and advertisement cost. Marketing and advertisement, you will be very high cost, and, you know, they will probably, you know, sign big celebrities, so you will see Virat Kohli coming in and all of that things. So that is just to get into the market penetration. So they want to acquire your market share. So at that phase, in introduction phase, you will have very low margins, your margins will be low, and your expenditure will be very high. Okay, because your sales did not, you know, reach that much of a level where your average cost of production is low, so your cost will be very high, so that is why your margins will be very low. Okay, and in growth what happens, so your sales gets picking up. Okay, so your average cost goes a little down, but still your marketing and advertisement expenses and your overheads are high. Okay, so because it is still growing, they even want to get into more market share. They want to capture more of the market. So that is a growth phase of any product. And maturity. In maturity, so here what happens is the company has reached a good market share. So your marketing and advertisement costs, they come down a little. So they are not very aggressive in marketing that product. Okay, and your margins improve, your profits grow in this phase. And here they try for differentiation of, you know, they want differentiation of the product. So they want to make your product in such a way that it is different from the competitor and it is not replaceable. So the company is trying to prevent it from going down. So for that, they will try to achieve the differentiation. So that is your maturity or saturation phase. And decline is when the today business is very innovative. So some new product comes, you know, some innovative product comes that has more features, and, you know, it has better use than your product. In that case, your product will be in a decline phase. Okay, so this is a typical product life cycle. So this is not a product life cycle for all the products, but mostly for, you know, FMCG or, you know, your day-to-day stuff, you know, your consumer goods. So your consumer goods, and, you know, for tech technology stock, for technology mostly, so for laptops and phones. Right. So one phone will not be there forever. So it will come, it will have a peak, and then the next model will replace it. Right. So this is a for the very fast changing industries where innovation is high innovation. So in that case, you will have this product life cycle. Okay. Okay. Okay, so the last part is called design thinking. Okay. So what is design thinking? So what is the main aim of a design thinking? Design thinking is nothing but they want to find innovative solutions to a problem. So innovative solutions to a problem. Right. So based on the problem statement, they will want to find an innovation solution, or they want to develop an innovative product to solve this problem. Right. So a great example for this is UPI. Right. So in UPI, what happens? So before UPI, what happens? So everywhere you have to go, you have to take cash, you have to take the exact change. The shopkeeper might not give you exact change. He'll give you, one chocolate, or, one eclairs, or, 5-star if he doesn't have a change. Okay. And again, the shopkeeper, he will have to take all the money, and then he'll have to deposit it into his bank. Or when he's paying, again, he has to withdraw and pay, or he has to give a check to his buyer or his seller. And so UPI, what does it do? So it solves that problem. So today, even from 1 rupee to 1 lakh, there's no need for you to do anything. You just scan, pay, and then you are done. So this is just solving problems, finding innovative solutions. Right. So what is the process of this? So there's a 5-step, it is not a 5-step process, but it has 5 stages. And we have to note that these stages, they are not one after the other. Okay. So this keeps happening parallelly. You can come back to one stage, go up, and you can do. Okay. First is empathize. Then define. Ideate. Prototype. And the last one is test. Okay. So what is empathize? So what is empathy? What does empathy mean? Exactly. So empathy is nothing but stepping into one's shoes, looking at a problem from his point of view. Right. So that is empathy. So you have to, empathize with your target customer. So you have to get into his shoes, and you have to see, okay, if I am a shopkeeper and I am having this problem, so what is my problem? So I have to take change, I might not have change. So that kind of a thing. So empathize, feel the problem, right? And then define the problem correctly. So you have to define your problem correctly. If you do not have the clarity of what it is you're trying to solve, then you cannot solve it, right? You have to know what you are solving. What is the problem you are solving? So you have to define your problem correctly, right? And then ideate. Ideate is brainstorm. So what can be a solution, right? So you have to come up with different kind of solutions. So how can we solve the problem? You can have bank transfers, you can give checks or something. So you have to come up with different kind of ideas. And based on that, prototype. Prototype is nothing but, it is a model. Okay. It is a model. So you're building one model to see whether it works, how it works. Okay. And then test. So once you develop the model, you have to test it. You have to find what all deficiencies are there, how you can improve the product, what all features are missing, what features you have to add, all of those things comes from testing. So you test, again you include it in a new prototype, you test until you get a perfect solution. So this type of activity is known as design thinking. So you are designing your solution. Okay, so you are designing an innovative solution to the problem. So this is the process which you have to follow. Right? Okay. So we have completed 3 units. We have completed 3 modules. That is just 15% of your, marks. So I'll be starting the next topic, that is PPC, in the next class. So this is a big topic, and please try to attend this because that is 20% of your total OMSM. Okay. So 20%, that's huge amount. So this is an important, there are many problems. Okay. So we will start that in the next class. Right? Any doubts? Okay.
No.
Thank you.
Thank you, sir.